Okay, good morning, everyone. Uh, Questions. How did the homework go as usual? And please you put your questions on chat. I hope you've done them. Can we review number 3 from the packet today? Okay, we can do that. Any other questions? Okay, just give me a minute to put it in front of me because I don't have it in front of me. Okay, any other question beside this? I don't think I didn't. I thought I did. Uh, I didn't see anybody else have the same issue. Anybody else didn't see any. There isn't. Okay. All right. I apologize for that. I thought I did. I may not have hit the publish button. Okay. I'm going to assign them all over again because I don't want to do a problem that you guys haven't thought about. I will go over what Erin said and I will start next section. And for tomorrow, you will have work problem as well as the new thing I will be talking about. So this is the worksheet that I gave you. That's the problem that your classmate is asking about. So a triangular tank with height 2 meter and width 6 and length 10 meter from here to here is full of water. Write down but do not evaluate an integral to find the work required to pump all of the water out from the spout at the top of the tank. So we have like some kind of a spout here and we're going to pull all the water. And again, use the fact that water weighs 1,000 kilograms per meter cube. Okay, so our process is always the same. We're not really changing. First, we introduce a reference point. So whenever I write a y, it means the distance from 0 to whatever my y is. And I divide this into layers. So always the process is going to be the same. So this is my layer. And so this is the layer. And then I focus only on that layer. It means in my mind, that's the piece I'm going to lift. I forget about the water above. I forget about the water below and total focus on the layer. Okay, so we're gonna find, we have to find the work done on a layer that is Y unit above the base. The base, okay. All right, so as we know, as we said several times, that's the heart of it. Once I find the work on a layer, I can add them up. Okay, so what's the work on the layer? It's, of course, we know it's the distance times the force. So we compute every aspect of it, the distance by which a layer, the force, which is how much it weighs basically, and find work on a layer. Now, the layer is Y unit right here. This is my Y from here to here. So the distance is going to be 2 minus Y. That's the piece we've done several times. The force, again, is the mass times the acceleration, which is we write in a G for simplicity. The mass is the density. I'm going to call rho. Rho stands for density times the volume of the layer times the acceleration. Okay, so the problem usually is finding the volume of a layer. So what you guys have to ask yourself, is the volume changing with how high is the layer? So is that two things? Is it this volume changing with the height? What's the shape of a layer? So the shape of the layer here is a rectangular prism. So it's not a disk. So the shape is a rectangular prism. So to find the volume, we're going to need the width from here to here times the length times the delta y. And question number 2, is the volume changing with height? Definitely. If I take a layer here versus this layer, definitely the volume is changing. So now let us find the volume of a layer, and this is we do it right here. Okay, what's the volume? That's a parallel, this is a prism, rectangular prism. So we need this, let's call this is the width, and this is the length, and this is here the delta y. So to be able to find the volume, the width is problematic. So I'm going to take this rectangle, this vertical rectangle, reproduce it to right here. That's my rectangle. That's this rectangle, I reproduce it. This is 0. From here to here, that's my 2. And this is my y, and I need to find the width. The width is this one. That's the width. All right. And now you can do this problem algebraically. You can do this problem geometrically. All right. So algebraically, it means I need to find this horizontal distance. So the easiest way is to find half of it. So we can call this x if you want. So we're going to do it algebraically. I call this x. Once I find x, the width, it will be 2 times x. So I introduce my x and y axis. And I need to find the equation, not the slope. I need the whole equation. All right, so this point here, to find the equation, I need to point 0, 0 on it. Let's see what this point. This is 2 here, and this point is 2, 3, because this length here is 6. So the slope is 3 divided by 2. And since it goes through the origin, it means the intercept is 0. That's x. So this will give me that x is 2/3 of y. So if I know y, I know x. So my w is 2x. I'm doing something false. Sorry, that's 3, 2. Okay, that's 3, 2. So this is going to be, my apologies. So y is going to be 2/3 of x. I mean, fine. Rise is 2. And from here to here, we have 3. Okay, so it means that the x is 3/2 y. So w is 2x. It means it's equal to 3y. Okay? Any questions? All right. So what's going to give me the volume? So the volume is going to be rho times the width, 3y, times the length, which is 10, times the delta y, times the acceleration. And finally, the work done on a layer is force times g times the distance. And at this stage, I rewrite as usual to make the delta y shows up much easier, so I can recognize in Riemann sum. So this is going to give me 3 times 10, that's 30 rho g. So 30 rho g times y times 2 minus y delta y. So the total work is going to be the integral from 0 to 2 of this piece right there, which is not hard at all as far as integration is concerned. Okay, so we're going to get those out. Integral from 0 to 2 of 2y minus y squared dy. All right? Any questions about that? I got confused how you got the radius to be 3y and not 3/2y. It's not the radius, be careful, it's actually the length. There is no radius in this problem because every layer is a rectangular prism. And then Did you understand how I got the x? Aaron, you can speak up.
Yeah, I mean, I see the where you solve it in terms of like
Yes.
y there.
But
Yeah.
y, w is twice x because it's from here all the way to here. That's the width of the rectangular prism. You see
Okay,
it?
now I see it. 'Cause you had double that for the whole length. I
You have
got
to
you.
double it. Yes. Does this make sense?
Yes.
Yeah. And when you double it, you get the 3y. You have to double it because otherwise you're taking half. You're taking from here to here. We double it to be able to get 3y. Okay. Any other questions? All right. So please do your homework for tomorrow. I apologize for not putting it. You guys should have told me because I always assign homework most of the time at least. But I thought I did. I honestly thought I did. All right. So today we're going to start section 8.1. So we're going to start integration. And I will assign, as I'm doing integration, as I said, I will assign all the time a problem about work, especially for tomorrow. So we're going to do section 8.2, integration by parts. Before we do that, there are some integral that are going to show up with us so frequently that I would like to establish once and for all. Okay, and all of you by now know them, but I will have to make sure everybody know them. Okay, the following integral, so we're going to establish the following. Let us say the simple one, e to the 2x dx. Okay, and I ask you to evaluate the following integral. So 2x, we have an inside function, means we set u to be 2x, there is no way out. The du is 2 dx. It means a half du is the dx, which means that this integral will become the following. E to the u times dx, which is a half du. And this would give me a half e to the u plus c. It means a half e to the 2x plus c. Okay, so we've done this several times, but now we have to kind of memorize this antiderivative. So let us say now I have k constant, and that's the word constant is crucial here. And I have the antiderivative of e to the kx dx. What's going to be equal to? I can repeat verbatim the same thing. So instead of 2, basically, I have a k. Instead of 2, I have a k. Instead of 2, I have a k. I have a k. So I repeat verbatim. As long as k is a constant, I can absolutely repeat myself here. I have a k, and here I have a k. So antiderivative of e to the kx, k is a constant, is 1 over k e to the kx plus c. Antiderivative that you can use starting today. You don't have to show me the work because, as I said, they will come up quite often. Another integral that will also come up with us and with you also is the cosine of kx. It's the same thing. The only way to evaluate this is by doing a substitution. But the substitution will get me to 1 over k, the sine of kx dx. Sorry, sine of kx. Differentiate this, you'll get that, no question asked. And finally, the same thing with the sine. This is minus 1 over k cosine of kx. So those integral will have to be added to the list of integrals that we know. It's not a lot of them, but this has to be added because, as I said, of the frequency in which those integral will come up with you in this course and in your later courses. Now I'm going to put two simple integral in front of you, not simple, sorry, two integrals in front of you, and you will have to tell me which is easy and which is hard, okay? So suppose I give you, the question is, which is easy, which is hard? Which is hard? All right, here my integral. Integral 1 is find the antiderivative of x, e to the x squared dx. Integral 2, x, e to the x dx. Quickly, which is easy, which is hard, or at least you don't know it yet. Quickly, I need answer. Aaron tells me, okay, so let us see which, all right, my question probably is not clear. Which is, let me get rid of that. Which is easy now? Now I want your answer again. Which is easy? 1 or 2? 1. You agree 1 is the easy. How do you do 1? What do you see when you see 1? We see an inside function immediately, and we see its derivative up to a constant looking at us. That's the typical scenario. That's the classic scenario of an integration by substitution. So this is easy. Easy. So we're going to set u to be x squared. The du is the 2x dx. So half of x dx, half a du is x dx. And this will become the integral of a half e to the u du. It means it's eventually going to be a half e to the x squared plus c. And of course, if we differentiate this piece, if we differentiate that correctly, I will have a half times the derivative of this times x squared, which give me x e to the x squared. So that's very easy problem by now. It's the heart of the substitution. This one is problematic. Why it is problematic? I cannot do any substitution, pure and simple. So u equal x, okay, big deal. I'm not doing anything if I said u equal to ex. So the question is how to integrate those type of functions, right? Before I go on, a remark that I've done several times. Most of you are not doing this mistake anymore, but some are doing it. And the mistake is some students, I have very few students who are still breaking an integral when we have a multiplication. And that's absolutely, absolutely, absolutely false. You cannot break the integral. So whenever I have a product, I have a problem. Substitution solves some issues, and today we're going to start another issue. So be very careful for those who are breaking the integral. It's absolute nonsense. So that's the problem. How are we going to integrate this? Right. Chain rule, sorry, integration by substitution is basically reversing the chain rule in a very systematic way. Today we're going to kind of reverse the product rule, not the chain rule. So let us start establishing how we're going to solve this problem. So integration by parts. We will derive the formula and then we will work with it. So integration by parts. Okay. So first, let us remember the product formula. Let's see the product rule. Suppose I have two functions, u of x times v of x. Those are two functions. And I find their derivative. Okay, so let's see what does the product rule tell us. What's the derivative of the product? It's the derivative of the first times the second function plus u of x times the derivative of v. So that's the product rule. Okay. Now I'm going to integrate both sides. I said since those two functions are equal, it means the antiderivative of that, dx. So the antiderivative of this piece is equal to the antiderivative of that function plus the antiderivative of u of x, v prime of x, dx. Okay, so I'm finding the antiderivative of those. Since those are equal, they have the same antiderivative. Now, what's the antiderivative of this one? Quickly on bright space. What's the antiderivative of that? Don't be afraid from symbolism. The same, exactly, just the same. It's u of x times v of x. Antiderivative for the derivative is the function itself. So I don't have integral in here. So this is going to be the integral of u prime of x times v plus the integral of u of x times v prime of x dx. Okay, that's what we have so far. Of course, still jumble mumble, and I 100% agree with you. Now I'm going to do more jumble mumble if you want. I'm going to do some algebra. I'm basically when I bring, I'm going to bring this term basically to here. That's really what I'm going to do. Okay, so this is going to give me that u of x times v minus the integral of u prime vx dx equal the integral of u of x times v prime dx. Okay. So I'm just moving things around. And this will give me the following. I'm going to write this to the left, this term to the left. This will be the integral of u of x times v prime of x dx equal to u of x times v minus the integral of u prime times v of x dx. Okay, so a little bit small comment. I know that this formula doesn't make much sense to you, but slowly, you'll become in the second nature to all of you. So what this tells me that this integral, basically, it takes one function to its derivative. That's what this will do. And takes another function, which is the v prime, to its antiderivative, which is v. That's really what this function does for us. Now, to simplify, since it's a bit hard to memorize this function, so to simplify the formula, we're going to write the following. dv for v prime of x dx. And this is to simplify the writing. Okay, so v prime of x dx, because we know that dv dx, we've used this idea several times. We know that dv dx, that's a notation for the derivative. So we multiply by dx symbolically, and this would mean v prime dx. So we're going to write dv for v prime dx. And I will do the same for du. And we're going to write du for u prime of x dx. Okay, so this is to simplify basically the formula and help us to memorize it. With this writing, this formula will become the following. That's a u times, instead of writing v prime dx, we'll write integral of u of x dv, or usually simply integral of u dv equal to u the function u, times the function v, minus the integral of u prime dx. So u prime dx, this will be the du, and this is the v. So again, what this integration by part formula, so this is called the integration by parts formula. Okay, so we call this integration by parts formula. So what the integration by parts is going to take one function u basically to its derivative and another function to its antiderivative. All right, so now let us practice it. Let us practice this formula. Okay. So evaluate the following. Integral of x ex dx. As we said at the beginning, this is a hard integral. Substitution totally collapse in this scenario. The integration by parts required from us to choose one of the pieces here to be a u, one of the pieces to be the dv. And this choice will be ours, but with practice, it's going to be easy for you to make the choice. So the first step is we're going to choose one to be the u, one to be the dv. So I will keep here track with how the formula works so we can refer to it. Tells me that integral of u dv, absolute memory, minus integral of v du. So this formula will stay for us for the next 2 days. All right. So the first step is to pick. All right. I will pick myself. So I'm going to pick u to be x. Now, a note here. I know that we use u for substitution, but this is not the u of substitution. I don't know why mathematicians are using the same letter. I hope they don't, because it's confusing for the student. But since you're told, you should not be confused. This has nothing to do with the u of the substitution. We're just using the same letter. That's only it. So it has nothing to do with substitution. Okay, so I'm going to put u to be my x. Once you choose your u, whatever left over in the integral, once you choose it, everything left over, you choose it to be the dv. So as I said, you make the choice. Once you choose your u, the leftover piece will have to be the dv. So I'm going to pick my dv to be the leftover. It means e to the x dx. So I made my choice. Now, to apply the formula, I have my u and I have my dv. The formula will require from me to find the du. I need that. And to find the v. So before we proceed any further, we have to find. So this is my u. I need to find the du. So the du, it means the derivative of that times dx. So that's the du. dv, I need the antiderivative. So this would give me that the derivative of that is e to the x. It means v is the antiderivative of e to the x dx. It means the v is e to the x. Don't worry about a constant at this stage. We add a constant once we're done with integration. So now let's see this is equal to. The formula tells me that this is equal to u times v minus the integral of v du. Okay, so now we substitute. My u now is the x times the v, which is e to the x, minus verbatim integral of v is ex times the du. The du is my dx. So finally, I'll get x ex minus the antiderivative of that is e to the x. End of the problem. Okay, so the antiderivative of xex is xex minus ex. Let us check just because, make sure. Let us check. I'm going to take the answer and differentiate it. I should get exactly this piece. Okay, let us differentiate this. This is a product. To differentiate, I use the product rule. Derivative of x is 1 times ex plus x times the derivative of ex is ex minus derivative of ex is ex. We get x e to the x. Absolutely correct. Okay, so that's the antiderivative. All right, so let us talk a little bit about what we did in these problems. As I said, the most important part is for you to choose the u and your dv. It's going to be really totally up to you. When we're choosing, there are two things that should happen. The integration by part transform, it does not solve the problem. It transforms one integral, is transforming one integral basically to another one. This is never a constant. So when we are choosing our u and v, we should always, most of the time, make sure that the integral that we are transferring to is easier than the original integral. So if you end up with something harder than the starting point, it means your choice of u and v is hard, is wrong. So that's help us really to decide what's happening. Note number 2, when you are picking your dv, you need to integrate it. It means you have to also make sure that you know how to find the antiderivative of the function, which is dv. Okay. Now, let us say, for the sake of argument, before I do other example, let us say for the sake of argument, I did not pick u and dv correctly. You don't have to write. I want you to listen. Okay, let us say the following. Okay, Joe didn't listen well to what Professor Elias said, and he picked u to be ex. Let us say I made this choice, and dv to be dx, because that's how integration by part. You make your own choice. And let's see, so this is his x dx, and you make that choice. And then he went correctly. He did everything correct. The du, he picked du, which is the derivative of ex dx. And he went to v, it's the antiderivative of x dx. It means a half x squared. So Peter kept going. So this will gonna give me. So this is, in my case, this is the u, and this is the dv. So after that, he kept correctly uv minus the integral of v du. All right, so what does he going to get? U is easy, is ex. V is a half e to the x squared minus the integral of v du. V is a half x squared. Du is ex dx. Okay. How can Peter know that his choice is wrong? Okay, because you guys will have to make the choice. What's wrong with this choice? Anybody?
Significantly harder than the first integral.
Absolutely harder than the first one. So the choice is yours, but if you end up with something harder than your starting point, you scratch this and you go back and make a change. All right, so that's really one hint how you have to make your choices. Okay, now we're going to do a bunch of integral. The second one I'm going to do is relatively easy. So find the integral of, for example, number 2. Find the antiderivative of, again, I'm going to do x sine 4x dx. Okay. So this is again a problem where substitution is out of the question because the derivative of 4x is 4. I have x staying here. No way I can get rid of the x. So we're going to do the same kind of work. We're going to set u to b. So I'm going to make u to be x. And the minute you guys choose your u, the leftover has to be the dv. So this is my u, sorry. The leftover is dv. You don't have choices for dv once you pick your u. The whole you have to pick whatever is left. So my dv is going to be the sine of 4x dx. That's my choice. Now you have to find the derivative. The du, the derivative of x is 1 dx, and I insist you write dx, not 1. The dv. Okay, dv is this. It means the derivative is the sine for x, but I need the v. I need the antiderivative. So v is the antiderivative of sine of 4x dx. It means, now based on the comments I did a minute ago, antiderivative of sine, I have constant times x is 1 over 4 cosine 4x. Okay. Now I have the pieces. Now I use the formula verbatim. I keep writing it till it becomes a second nature to you. So it's uv minus the integral of v du. U go to its derivative. This one go to its antiderivative. That's how it's working. Okay, u is x. V is minus 1 over 4 cosine of 4x minus the integral of v, which is minus 1 over 4 cosine of 4x dx. So I will have minus 1 over 4 cosine 4x minus minus plus 1 over 4 integral of that dx. So now I look at this, I say, is it easy? Yeah, it is very easy. I am on the right track. I keep going. So finally, this is going to be equal to minus 1 over 4, the cosine of 4x, plus 1 over 4 times cosine 4x dx. As I said, I want you kind of memorize those because how often they show up is again another 1 over 4 sine of 4x. So finally, I will have minus 1 over 4 cosine of 4x plus 1 over 16 the sine of 4x plus c. Differentiate it, you get exactly what you have. If I'm not mistaken, you missed x on uv, did I? U is x, right? And v is this one. Kim, Kim, right? What's confusing you? Oh. Thank you very much. Thanks. Okay, thank you. All right, problem number 3. I'm gonna put the problem in front of you, and even though I don't see you, I'm gonna give you a minute and to think about it and tell me how would you approach it. Even though I don't see you, but I insist that you work on it by yourself. So example number 3. Okay, I'm gonna take the following. Integral of. Kim, are you settled down? Kim, are you okay? It's x, you're right, x and x. Yeah, thanks. All right, so integral of x, ln of x dx. Okay, as I said, I don't see you. I do want you to spend a minute thinking about it. And then guys, tell me, what did you do while I'm drinking my coffee? Okay, the minute is not over yet. I'm counting. You still have a few seconds. Right, ideas. Any difficulties? Anybody has any issue with it? So what's your U? Don't write yet. We'll have to discuss it. What did you guys pick your U to be? I have Aaron. Anybody else beside Aaron? Okay, since everybody agree, we're gonna put U to be X. Okay? All right, so if U is X, du is dx, no problem with that. What's going to be my dv? Remember what I said, I was very clear. Once you pick your U, leftover has to be your dv. So what's gonna be the dv? The ln of x dx. Am I right? So du is easy, that's derivative. As I said several times, everybody can learn how to differentiate. So now it means here dv dx is ln of x. So what's gonna be the v? It's the antiderivative of the ln of x dx. Are you with me so far? What's the antiderivative of ln? What's the antiderivative of ln?
1 over x plus c.
Okay, true or false? True or false? All of you. False. Absolutely false. Why it's false? Because what's the derivative of 1 over x? Is it ln? What's the derivative of x to the minus 1 is minus 1 over x squared. It's definitely not ln of x. Okay, so you should be careful. The derivative of ln is 1 over x. But the antiderivative of ln is a big question mark. You guys understand what I'm talking about? So what's going to be the issue? If I make your choice, which is, of course, I'm expecting you to do that, dv will have to be the ln. It means you will have to find the antiderivative of ln. As of this minute, probably in the next few minutes, you will be able to do that. As of this minute, we don't know what's the antiderivative of ln. We don't know what's the function whose derivative is ln of x, because 1 over x is the derivative of ln, not the antiderivative. So based on this, I'm going to scratch this choice. It's not going to work. The difficulty was right there. Okay, so what I'm going to do now? If this choice failed, what do you want me to do? I write the problem again, and you give me ideas. What's the other choice? We have to make Q to be ln. I don't have other choices. I'm going to make Q to be the ln. Once I pick Q to be the ln, the leftover, whatever it is, have to be my dv. So what's left over here? X dx. And I go from there. All right, so let's do that. If U is equal ln, the du, the derivative of ln, is 1 over x dx. dv is x dx. It means the derivative is x. It means v is the antiderivative of x dx. The antiderivative of x dx is 1/2 x squared. So now I'm doing all this to the side. Now this is done, I apply, it's u v minus the integral of v du. And now we substitute verbatim. U is the ln. V is 1/2 x squared minus. So uv is never a problem once I can evaluate everything. Minus v. Now what is my v? My v is 1/2 x squared times the du. The du is 1/x dx. Okay, so this is going to be equal to 1/2 x squared ln of x. I'm just switch them around because it's nicer to write it this way. Minus 1/2 is a constant. Now I definitely not gonna break this integral. We now remember we cannot break, we just simplify. X squared times 1/x. This is x. So it's x squared over x, which is x. Now I don't have any issue with this problem anymore. This is that's a very easy integral. So finally I will get 1/2 x squared ln of x minus 1/2 times antiderivative of that is 1/2 x squared plus c. So finally I'll get 1/2 x squared ln of x minus 1/2 times 1/2 is 1/4 x squared plus c. And now, of course, you can differentiate this and you should get exactly x ln of x, no question asked. All right, so we have to be careful with our choices. So as I said, there are two things we have to watch for. The first thing is to have to make sure that what we end up with is easier than our starting. The integral, because integration by part does not solve the problem. It transfers the problem. It gives me one integral in terms of another integral. Hopefully, this one should be easier than the first one. That's how it works. So it doesn't totally solve it. So we have to make careful with our choices. And also we have to make careful with our dv, because when we pick your dv, we have to make sure we can find the antiderivative, which is always, as I said, antiderivative are not easy. Antiderivative are way, way harder than derivative. All right. One last example is the following. Okay, when we were doing this problem, we stumbled on the ln. So now my last problem is find that. Can you see it recursively? If the resulting integral is still difficult, we will do that tomorrow, Jonah. Yeah, we will do some of this tomorrow. For today, I won't do that. Tomorrow I will answer your question with an example. All right. Now I put this in front of you and I want ideas. So we will find the antiderivative of ln. We will do it integration by parts, but that's the only way out. So we're gonna pick a u and we're gonna pick your dv. Okay. So what do you think the u is going to be? Maybe ln? Yes, we have no other choices. I mean, it's not like I have choices in this. We're gonna pick this u to be ln. I don't really have any other choice. Once I pick my u, as I said, the leftover, whatever it is, this is my dv. Okay, so the dv is going to be the dx. And now I proceed verbatim. If u is ln, the derivative is derivative of ln. Remember, that's the derivative is 1/x dx. dv is dx. It means v is the antiderivative of dx. The antiderivative of dx is just x. We don't worry about constant for now. And now I replace verbatim. That's going to be u times v minus the integral of v du. Okay, now what is u? U is ln, v is x minus integral of v du. V du is 1 over x dx. Okay, so finally I will get x ln of x minus. Now, of course, we simplify. When we hit here, we simplify. Whenever you have integral and you have the same exponent of x, you just definitely simplify. So this is obviously x times 1 over x is just 1. So this is minus the integral of dx. Finally, I end up with x ln of x minus x plus end of the problem. And now you differentiate this. Let's just check. Equal. Let's differentiate. Right? From here to here, that's the product rule. It means the derivative of x, which is 1, times ln plus x times the derivative of ln is 1 over x minus derivative of x is 1. So I will be left with ln of x plus 1 minus 1, which is the ln of x. So check is absolutely correct. Okay. So now we know the antiderivative of ln, and by parts is basically the only way to find the antiderivative of ln of x. There is no other way to do it. Okay. All right. So for tomorrow, I'm going to assign what I was planning to for today, part of the work problem. And I will definitely assign a bunch of problems that deal with integration by parts. So hopefully tomorrow, we will be in school, not online again. Okay. Any questions before I let you go? Any questions? Okay, then stay safe and stay indoors if you can. Bye and see you tomorrow.